So let's finish this year off. Advent of Code 2024, day 25. The last puzzle is called Code Chronicle. Went back to the alliteration, I see. Out of ideas and time, the historians agree that they should go back to check the chief historian's office one last time, just in case he went back there without you noticing. When you get there, you're surprised to discover that the door to his office is locked. You can hear someone inside, but knocking yields no response. The locks on this floor are all fancy, expensive virtual versions of the 5-pin tumbler locks. So you contact North Pole Security to see if they can help open the door. Unfortunately, they've lost track of which locks are installed and which keys go with them. So the best they can do is send over schematics of every lock and every key for the floor you're on. The schematics are in a cryptic file format, but they do contain manufacturer information, so you look up their support number. Our virtual 5-pin tumbler product, that's our most expensive model, way more secure than... Explain that you need to open the door and don't have a lot of time. Well, you can't know whether a key opens the lock without actually trying the key in the lock, but you can rule out some of the key lock combinations. The virtual system is complicated, but part of it really is a crude simulation of a 5-pin tumbler lock, mostly for marketing reasons. If you look at the schematics, you can figure out whether the key could possibly fit in a lock. He transmits you some example schematics. Okay. The locks are schematics that have the top row filled and the bottom row empty. The keys have the top row empty and the bottom row filled. All right, so we're going to be just reading a bunch of grids. Okay. If you look closely, you'll see the schematic is actually a set of columns of various heights, either extending downward from the top for locks or upward from the bottom for keys. For locks, those are pins. Those are the pins themselves. Okay, you can convert the pins and schematics to a list of heights, one per column. For keys, the columns make up the shape of the key where it aligns with pins. Those can also be converted to a list of heights. So you could say this first lock has pin height 05343. Sure. Okay. Or the first key has heights 50213. These seem like they should fit together. The first 4 columns, the pin and keys don't overlap. However, this key cannot be for this lock. In the rightmost column, the lock's pin overlaps with the key, which you know because in that column, the sum of the lock height and the key height is more than the available space. All right. The sum of the lock height and the key height is more than the available space. Okay, so if we convert the keys into numbers, I'm assuming the puzzle input looks like this. Let's take a look. Yeah. Okay. So anyway, you can narrow down the keys you need to try just by testing each key in each lock, which means you have to check, wait, you have how many locks? The only installation that size is at the north, you disconnect the call. In this example, converting both locks to pin heights produces this, and converting all 3 keys. Okay, and then we just try and see. In this example, the number of unique lock key pairs is 3. How many unique lock key pairs fit? Okay, so it looks like we've got 4,000 lines, and each lock is, or key is 1, 2, 3, 4, 5, 6, 7, 8, including the last one. But the last one doesn't have the last one. So it's 4,000 divided by 8, just 500 locks and keys. All right. Converting these seems like it's straightforward. There's something I'm stuck on though. Because it says they send you the schematics of every lock and every key for the floor you're on, your puzzle input. But my puzzle input is not that. It's, oh wait, it does say example schematics, but they were transmitted from, okay. Maybe I just misread it or was misthinking. I thought we had 2 different sets of things, but we just have one. So I think we're good. It looks like it might be as simple as just scanning each one. If it starts with a hash, then we know it's one of them. Which one is this? This is a lock. So a lock starts with a hash and a key starts with a dot. And it said something about every lock has the top row filled. Locks have the top row filled and the bottom row empty, and then keys are the other way around. So we always know if what the first row is going to be once we look at the first character, and then we can just add up the values here. This says pin height 0, 5, 3, 4, 3. So we can just add as we go, right? And we can add as we go. We could just scan downward. Okay, so I do have a read records. Let's take a look at that. Lib.rs, yeah. Is it down here at the bottom? Read text records, no. Thought I have read num records. Oh, okay. Read single line, read numbers. And then this is the, this stuff belongs in a different thing. And then we have read text records. Oh, I do. Okay. So this would get it for us. But this throws away. Oh, maybe it doesn't. Maybe it doesn't. Let's try read text records and see what we get. So read text records. And I'll just say println this line 0. Let's call it records. And see what it looks like. Okay, so we do get the full thing with the new lines. So each one can be split, and we can just parse each one. So let's create a lock or key. Maybe we can make that this way. Enum schematic. And it's going to be a lock, which contains... Do I want to use a vec here, or do I just assume everything is 5 wide? Use size 5. We can do that. And then key, same thing, use size 5. And then we'll import from stir for schematic. Like this. And then here we'll just look at, we'll split it up by lines. Split it by new line. There is no new line at the end, so we don't have to worry about a trailing blank there. Actually, I don't know. What does the last one look like? It might have the new line on it. Let's find out. Records len -1. What does that one look like? Let's comment this out so I can actually get it to build. Yeah, it does have the new line at the end. So we're going to have to deal with that. Okay. This. Filter line. Line is empty. Collect vec. All right, so now these should be all of the lines of the schematic. So we can see if we have a lock or a key just by looking at the first line. Lines 0 equals 1, 2, 3, 4, 5. Then it's a lock. So we say for let mut, let's say pattern equals 0, 5. And then we can just add pattern as we loop over the lines for line in lines 1 dot dot. Oops, like this. And then for each column within the line, we're going to see if there's a hash. And if there's a hash, we'll increment that value. That should do it, right? For col. No, for index. ch. Oh, let's say call. ch in line chars enumerate. If ch is equal to a hash, then we'll say pattern of call plus equals 1. And that should give us, actually we could do that regardless of lines of 1, right? And then we could just base that here. If it's this, then we're going to say, okay, schematic, or self rather. And I keep forgetting if it's the lock or the key. The lock has the hash. Okay, so this is a lock. Else it's okay. Key pattern. All right, let's see if that builds. It says consider changing this thing here. Oh, because I'm not using it. Okay, but I will. I will. Because now we're going to parse these out. Schematics is a vec of. Oh, we'll do this. Locks is a vec of schematics, and keys is a vec of schematic. And we'll just parse them out separately. But we can do that using a partition, right? First, we need to convert everything. Equals records. Let's say a vec of schematic is equal to records iter map record parse unwrap. Actually, I don't need to do this. I have a function to do this. I just wrote that in a previous live stream. Collect. Let me see if this builds though, and then I did write this. What did I call it though? Did I put it in lib? Yeah, parse lines. See, it just does the work as long as it knows the thing. So we just need to pull in line parser. Parse lines. So we should be able to just do that as soon as we pull in line parser. Yay. Okay, so now we want to partition that into two separate locks keys is equal to schematics partition. Schem, I guess. And then we're going to say matches bang. If it's a lock, do I do it like this? Does partition return a tuple? Oh, iter. Yeah, it does return a tuple. Okay. But doesn't like that. Type must be known at this point. So do I have to say, tell it what kind of tuple? Vec. Even, can I say this? I guess it's been a while since I used partition. Oh, do I have to give it both types like this? Oh, it's looking for the function. Oh, wait, I see, this isn't supposed to be hard. We were just supposed to run partition. Predicate passed to partition returns true. Force partition returns a pair, all the elements for which it returned true, and all of the elements for which it returned false. Right? And it just returns this tuple. But the type isn't known. The type should be known because schematics is known. It's saying type must be known at this point. So do I have to actually tell it here that this is a pair of vecs? Vec. Like that? I guess so. All right. And then we can just say self locks equals locks, self keys equals keys. And didn't like that because, oh, it found that. I'm partitioning it, but I'm not getting the actual thing. So I should probably do an into iter. And now, is partition from iter tools? No, it's part of the core. Well, actually, it says core iter traits iterator, but it's probably in standard iter. It comes with Rust. And now we should be able to print out like the first lock and the first key. Let's do that. Println lock locks. Let's just print them all. Self locks. And then we do keys. Yeah. So now we have a bunch of locks and a bunch of keys. Let's see. I have no idea if they should be in order based on the input file. So let's take a look at the input file. This says 12043. That makes sense, right? Okay, and then for the key, that would be this guy here, would be the first key. 13461. Oh, I'm off by something. Oh, because I'm doing the last line too, and I shouldn't be doing. This should be 02350. Okay, so let's fix that. Is that the way they translated it? Yeah, 50213. Okay, so I'm doing the last line. I shouldn't be doing the last line. Lines len -1. Right. The first lock is still 12043, so that still works. And the first key should now be 02350. Perfect. Okay. So now we just want to try every lock and every key, and we'll just write a fits function for this. Simple schematic. Fn fits lock self will hopefully be a lock, and then we try the key. We'll just assert that, I guess. Matches self schematic lock. And this returns a Boolean. Oh, and this, yeah, I forgot. Part 2, there's no part 2. So Merry Christmas. There we go. So this is going to just return false for now. I'm going to say nothing fits anything. And then we're just going to go down here. And for part 1, we're going to try every key and every lock. For lock in self locks. For key in self keys. And then maybe I can rewrite this in functional style. Let count. That way we don't have to do this with a mutable count. If lock fits key. That's the other way around. I want to see key if the key fits the lock. We need to make this proper English here. If key fits lock, count plus equals 1. And then that's the answer, right? And right now it's going to be 0. Right. And it's saying I'm still not using anything. So this is going to be the lock. Okay, so now we just add each one up. And they all have to be less than 5 if we add them up. Right, because 5 plus 0 is 5, 5 0 is 5, 3 and 2 is 5. Oh, they have to be less than or equal to 5. 4 and 1 is 5, and then 3 and 3 is 6, and that's the first one that's bad. So I'm just thinking, is there a way we can do this programmatically? Can I say, let LK is equal to, no, can I do this? Let's say schematic lock L comma, schematic key K is equal to self. Oh, I have it backwards. Lock and self. Will it let me do that to destructure? Oh, yeah, okay. Else to do. Oh, right. Else panic did not get lock and key. Self. No, lock, I keep doing backwards. And self. Okay, can I do that? It let me do it. Okay, so now I just need to say L dot iter. Can I iterate that? Zip K dot iter. Will this build? It built. Okay. So now I'm going to just compare map. And now I should have a pair of things that I want to add together. A and B. I guess the lock and the key. Right? That's an unknown and that's an unknown. That's a shame. Lval and kval. These should be the U sizes that we got there, and I can just say lval plus kval. What is this now? It is okay. So that's something. Expected closure takes a single tuple. Oh, a tuple. That's why it said unknown. Okay. All right, and now we can say any, maybe all, x is less than or equal to 5. Let's call it sum. Right? And we got 3201. Let's see if that's the right answer. Hey, that's the right answer. But here's the exciting thing. Now we continue to part 2. Part 2 is already solved. You and the historians crowd into the office, startling the chief historian awake. The historians all take turns looking confused until one asks where he's been for the last few months. I've been right here working on this high priority request for Santa. I think the only time I've ever even stepped away was about a month ago when I went to grab a cup of coffee. That's what kicked off this whole thing, right? Just then, the chief notices the time. Oh no, I'm going to be late. I must have fallen asleep trying to put the finishing touches on this Chronicle Santa requested. But now I don't have enough time to go visit the last 50 places on my list and complete the Chronicle before Santa leaves. He said he needed it before tonight's sleigh launch. One of the historians holds up the list they've been using this whole time to keep track of where they've been searching. Next to each place you all visited, they checked off that place with a star. Other historians hold up their own notes they took on the journey. As historians, how could they resist writing everything down while visiting all these historically significant places? The chief's eyes get wide. With all this, we might just have enough time to finish the Chronicle. Santa said he wanted it wrapped up with a bow, so I'll call down to the wrapping department and, hey, could you bring it up to Santa? I'll need to be in my seat to watch the sleigh launch by then. You nod, and the historians quickly work to collect their notes into the final set of pages for the Chronicle. I have enough stars to deliver the Chronicle. Let's do it. Using the notes from the places marked by all 50 stars, the historians finish the Chronicle, wrap it, and give it to you so you can bring it to Santa before the big sleigh launch. Santa is already in the sleigh, making the final launch preparations when you arrive. You try to hand him the Chronicle, but he doesn't take it. Ho, 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 he laughs to himself. That gift isn't for me, it's for you. That Chronicle is a record of all the places you've been and people you've helped over the last decade. Thank you for everything. With that, Santa takes off in his sleigh to deliver the rest of this year's presents. The end. All right, let's check out the calendar, because now, oh yeah, see, now it's animated. We get, oh, this was from year 1. I remember that. I don't remember which one the fireworks was in. I do remember this thing with the transit. And this was visiting the different planets, which I only got up to day 9, I think, on that one. And this is the monster from a couple years back. Nice. And then we have a little snowfall here. All right, cool. We're done. And it took me, well, 36 minutes of stream time. Let's go with Clippy here. Clippy's happy. Let's commit these changes. Git status, git add source, git commit -m 2024 day 25. And we're going to call it a stream. Nice quick stream for Friday.